The remainder theorem. The remainder theorem. This theorem makes it easy to find the remainder when you divide a polynomial by another polynomial. Now, this is the theorem. If, let's write the theorem. If the polynomial f of x is divided by x minus a, the remainder is f of a. Now let's take an example. The remainder is f of a. The trick is, if you are dividing f of x by x minus a, the remainder will be f of a. And if you are dividing f of x by x plus a, the remainder will be f of minus a. F of minus a. Just say x minus a equals 0 and x will be equal to a. So the remainder will be f of a. Here say x plus a equals 0, which means x equals minus a. So the remainder will be f of minus a. Now let's take a few examples to explain that. Find the remainder. Find the remainder when f of x, which is equal to 3x cubed minus 4x squared plus 2x plus 3 is divided by x minus 1. Let's go to the solution. First of all, I want to do it by the long division method. Let me use the long division method. I'm dividing 3x cubed minus 4x squared plus 2x plus 3 by x minus 1. 3x cubed divided by x, that's 3x squared. And now I multiply the whole of this by 3x squared. X times 3x squared, that's 3x cubed. Minus 1 times 3x squared, that's minus 3x squared. We subtract now. 3x cubed minus 3x cubed is 0. Minus 4x squared minus 3x squared. That will be minus 4x squared plus 3x squared, which is minus x squared. Bring down the next term, which is plus 2x. Now we go again. Minus x squared divided by x, that's minus x. X times minus x is minus x squared. And minus 1 times minus x is plus x. We subtract minus x squared minus x squared is 0. 2x minus x is x. We bring down the next term, which is plus 3. Now x divided by x, that's 1. We go to the multiplication. X times 1, that's x. Minus 1 times 1, that's minus 1. And now we subtract again. X minus x is 0. 3 minus minus 1, that's 3 plus 1, which is 4. So the remainder is, the quotient is 3x squared minus x plus 1, and the remainder is 4. That's by the long division method. Now let's try let's use the remainder theorem. If we divide f of x by x minus 1, if f of x is divided by x minus 1, the remainder is f of 1. Just say x minus 1 equals 0, and x will be equal to 1. So that means the remainder will be f of 1, will be f of 1. So f of 1 is the same as 3 multiplied by 1 cube minus 4 times 1 square plus 2 times 1 plus 3. And that's equal to, the cube of 1 is 1 times 3, that's 3. The square of 1 is 1 times minus 4, that's minus 4, plus 2 plus 3. And that's equal to 3 minus 4 is minus 1, plus 2, that's 1, plus 3, that's 4. And it's the same as what we got when we used the long division. So the remainder theorem makes it much shorter. This is another example. Find the remainder when, find the remainder when f of x, which is equal to x plus 3 times x minus 2, x plus 3 times x minus 2 times x plus 2 is divided by x plus 1. Let's go straight to the solution. F of x is equal to x plus 3 times x minus 2 times x plus 1. First of all, I like to open to expand f of x, and that simply means x squared minus 2x plus 3x minus 6 times x plus 1, which is x squared plus x minus 3 times x plus 1. And that's equal to x cubed plus x squared plus x squared plus x minus 6x minus 6, which is equal to x cubed plus 2x squared minus 5x minus 6. So this is f of x. Now, when it is divided by x minus 1, when f of x is divided by x plus 1, the remainder will be the remainder is f of, what do we say? We are dividing it by x plus 1. So if you say x plus 1 equals 0, x will be equal to minus 1. So the remainder will be f of minus 1. The remainder is f of minus 1, which is equal to minus 1 raised to power 3 plus 2 multiplied by the square of minus 1 minus 5 times minus 1 minus 6. And that's equal to, the cube of minus 1 is minus 1. Oh, this is 2 times minus 1. 2 multiplied by the square of minus 1. Now, the square of minus 1 is 1 times 2, that's 2. Minus 5 times minus 1 is plus 5 minus 6. And this is the same as minus 1 plus 2, that's 1, plus 5, that's 6. 6 minus 6, that's 0. If the remainder is 0, that simply means x plus 1 is a factor of f of x. Therefore, x plus 1 is a factor of f of x. That's why when we divide f of x by x plus 1, we don't get any remainder. So that's it. Now let's check by the long division method and see if the answer will be the same. F of x is x cubed plus 2x squared minus 5x minus 6. And we're dividing it by x plus 1. X cubed divided by x is x squared. Now we multiply x times x squared, that's x cubed. 1 times x squared, that's x squared. X times x squared, x cubed. 1 times x squared, x squared. Now we subtract x cubed minus x cubed is 0. 2x squared minus x squared is x squared. Bring down the next thing, which is minus 5x. X squared divided by x, that's x. X times x, x squared, plus 1 times x plus x. We subtract again, x squared minus x squared is 0. Minus 5x minus x, that's minus 6x. Bring down the next term, which is minus 6. And there we go again. Minus 6x divided by x is minus 6. X times minus 6 is minus 6x. Plus 1 times minus 6. That's minus 6. We subtract again. Minus 6x minus 6x. That's 0. Minus 6 minus 6, that's minus 6 plus 6, which is also 0. So when we get here is 0. When we subtract, we just get 0. So the remainder is 0. Whether you use a long division or the remainder theorem, the long division method or the remainder theorem, you get the same answer. So let's see that. Can we take another example? Okay, let me take another example, and now I can take examples from here. Let me take just one more example from here. Which of these questions is shown clearly? Okay, let me take this last example. It says when f of x, which is equal to x cubed plus px squared plus qx plus r is divided by x minus 1, x plus 2, and x minus 3. The remainders are minus 14, 16, and 36 respectively. Find the values of the constants P, Q, and R, and hence determine the quotient determine the quotient and remainder when f of x is divided by x minus 4. So let's go to the solution quickly. Now, f of x is equal to x cubed plus px squared plus qx plus r. When f of x is divided by x minus 1, the remainder is minus 14. When it is divided by x plus 2, the remainder is 16. And when it is divided by x minus 3, the remainder is 36. So that means if you divide f of x by x minus 1, the remainder is minus 14. That means f of 1, if you divide f of x by x minus 1, then the remainder is the same as, just say x minus 1 equals 0. That means x equals 1. So the remainder will be equal to f of 1. And that remainder is 14. So that means that remainder is minus 14. Which means f of 1 is minus 14. Because the remainder and f of 1 are the same. So that means f of 1 is equal to minus 14. And what is f of 1? F of 1 means 1 raised to the power 3 plus p times the square of 1 plus q times 1 plus r, and that will be equal to minus 14, which means 1 plus p plus q plus r equals minus 14. And that means p plus q plus r equals minus 14 minus 1, which means p plus q plus r equals minus 15. We can call that equation 1. When f of x is divided by x plus 2, the remainder is 16. And we know that when f of x is divided by x plus 2, the remainder is f of minus 2. So if that remainder is 16, that means f of minus 2 is equal to 16. It means f of minus 2 and 16 are the same. So, and what is f of minus 2? That will be the cube of minus 2 plus p multiplied by the square of minus 2 plus q multiplied by minus 2 plus r equals 16. The cube of minus 2 is minus 8. Now the square of minus 2 is 4 times p. That's 4p. Q times minus 2 is minus 2q plus r equals 16. And this simply means 4p minus 2q plus r equals 16 plus 8. Which means 4p minus 2q plus r equals 24. We can call that equation 2. When f of x is divided by x minus 3, the remainder is 36. And we know that by the remainder theorem, if you divide f of x by x minus 3, just say x minus 3 equals 0. That means x is equal to 3. So that means if you divide f of x by x minus 3, the remainder is f of 3. And they have told us that that remainder is 36. So that simply means f of 3 is equal to 36. F of 3 equals 36, which simply means 3 raised to the power 3 plus p times 3 squared plus q times 3 plus r equals 36, which is 27 plus 9p plus 3q plus r equals 36. And that simply means 9p plus 3q plus r equals 36 minus 27, which means 9p plus 3q plus r equals 9. And that's equation 3. Now, how do we solve the equations simultaneously? I can say from equation 1, r is equal to minus 15, this is equation 1. From equation 1, r is equal to minus 15 minus p minus q. Now I'm putting r in equations 2 and 3. I'm putting r in equations 2 and 3. So if I put it in equation 2, I'm going to have 4p, this is equation 2, I'm putting r in equation 2, 4p minus 2q plus minus 15 minus p minus q equals 24, which means 4p minus 2q minus 15 minus p minus q equals 24. And that means 4p minus p, that's 3p, minus 2q minus q, that's minus 3q, equals 24. When I take minus 15 to the right hand side, it becomes plus 15. And then I have 3p rather, minus 3q equals 39. And I can divide through by 3 to get p minus q equals 13. That's equation 4. Now if I put r in equation 3, this is equation 3. 9p minus 9p plus 3q plus r. And I know that r is minus 15 minus p minus q. So that's going to be plus minus 15 minus p minus q. And that's equal to, don't forget I'm putting it in equation 3, equals 9. So now I have 9p plus 3q minus 15 minus p minus q equals 9. 9p minus p is 8p. 3q minus q is 2q. If I take minus 15 to the right hand side, it becomes plus 15. So we have 9 plus 15 on the right hand side. And what do we have? This simply means 8p plus 2q equals 24. And I can divide through by 2 to have 4p plus q equals 12. And that will be equation 5. So I can see that equations 4 and 5 are in terms of p and q. So I can solve the two of them simultaneously. Equation 4 is p minus q equals 13, while equation 5 is 4p plus q equals 12. So I can eliminate q by addition. P plus 4p equals 5p, minus q plus q equals 0, and that's equal to 13 plus 12, 25, which simply means p equals 5. So if I put p in equation 4, p minus q equals 13, That simply means 5 minus q equals 13, which means 5 minus 13 equals q. Take 13 to the left hand side and take minus q to the right hand side. When 13 comes to the left hand side, it becomes minus 13. And when minus q goes to the right hand side, it becomes plus q. So this is minus 8 equals q, which is simply the same as q equals minus 8. Now what is r? We can now find r. R is therefore equal to minus 15. Don't forget, r is minus 15 minus p minus q. So that minus 15 minus p is 5, that's minus 5, minus q, that's minus 8. And that will be minus 15 minus 5 plus 8, which is equal to minus 15 minus 5 is minus 20 plus 8, that's minus 12. So that means p is equal to 5, q is equal to minus 8, and r is equal to minus 12. So what's the remaining part of the question? They said find the values of the constants p, q, and r, and hence determine the quotient and remainder when f of x is divided by x minus 4. They want us to do the long division. That's why they said we should find the quotient and remainder. So f of x, okay, now that I have found p, q, and r, I can state f of x fully. F of x will now become, what's f of x? This is f of x. This is f of x. We can put the values of p, q, and r now. F of x is x cubed plus px squared. P is 5, so that's plus 5x squared plus qx plus qx plus qx, and I know that q is minus 8. That will be minus 8x plus r. R is minus 12. Plus minus 12 will be minus 12. So that's f of x in full. Now that we have written x in full, f of x in full, we can use the long division method to find the quotient and remainder when f of x is divided by x minus 4. Let's do that. F of x is x cubed plus 5x squared minus 8x minus 12, and we are dividing it by x minus 4. Now x cubed divided by x, that's x squared. When we multiply x times x squared, x cubed minus 4 times x squared, that's minus 4x squared. We subtract now. X cubed cancels x cubed. 5x squared minus 4x squared, that's 9x squared. We bring down the next term, which is minus 8x. Now 9x squared divided by x, that's plus 9x. When we multiply, we have 9x squared minus 36x. Now we subtract again. 9x squared minus 9x squared is 0. Minus 8x minus 36x. That's minus 8x plus 36x, which is 28x. We bring down the next term, which is minus 12. And we go again. 28x divided by x, that's 28. When we multiply x times 28, that's 28x minus 4 times 28, that's minus 106. Is that correct? Minus 4 times 28. 4 times 20 is 80. 4 times 8 32. Minus 112. And now we subtract. 28x minus 28x is 0. Minus 12 minus 112, that's 100. So the quotient is x squared plus 9x plus 28, and the remainder is 100. And that's it, very, very simply. So do this as an exercise. Do this as a homework actually. FMP 1 exercise 6b, questions 15, 16, 17. Okay, try 18, 15, 16, 17, and 18. But let's see. 15, 16, 17. Yeah, that's it. All right, that's it. Very, very simply. Do it and send it to me.